The first section in Chapter 8 is titled Functions. And you'll start noticing some new slides that will be in the videos. There are slides that have our objectives for the lesson. So at the end of this lesson, you want to be able to determine whether a relation is a function, and you also want to be able to write a function using function notation. So let's look at a few vocab terms. First, we have independent variable. And other words that may be used in place of the word independent variable is input or domain. So the independent variable is the value is actually chosen for the function or equation and does not depend on the other variable. It's independent. The dependent variable, or the output or the range, means that the value depends on the input. So once you plug the input in, or the independent variable, your output is then the dependent variable. It was dependent upon the input. Please make sure you're writing these down. So let's recall that functions are relations in which each element of the domain is paired with exactly one element of the range. So if we look at the function on the left, we have the domain or the inputs. If we input a 2 into the function, we get a 1. If we input a 4, we get 3, 5, we get 4, and 9, we get 7. You can see that each element in the domain is paired with exactly one element of the range. That is a function. On the right, we have an example of a relation that is not a function. We have 2 that's being paired with 1 and 3. 5 paired with 4 and 9 paired with 7. You can think of these as ordered pairs. But because the 2 is paired with 1 and 3, essentially the domain is being repeated, it's not a function. So anytime the domain is repeated, it's not a function. Let's look at some examples. There are 4 here and they're kind of scrunched together, but it's pretty quick to pick out if things are functions or not. So determine whether the relation is a function and explain. We have a series of ordered pairs in this set: 54, 112, 56, 130, 55, 145, 54, 123, and 56, 128. And hopefully you can see right away we have domain being repeated in the 54 and the 56, so this is not a function. Let's look at number 2. Same type of problem, just laid out a little bit differently. We've got a table with ordered pairs: 4, 6, 7, 10, 6, 11, 3, 8, 5, 4, and 2, 9. And as you look across the domain, you can see that there are no repeats, so this is a function. Try 3 and 4 on your own. Are they functions? Number 3, we have 5, 1, 6, 3, 7, 5, 8, 0. None of the domain or none of the x values are repeated, so it is a function. Now, I did ask you to explain. I am verbally explaining. In your homework, you will need to write how you know that that's a function. Number 4, we have another table. Ordered pairs: 1, 7, 6, 6, 3, 2, 1, 8, 5, 2, and 2, 1. You can see that we have the ordered pair 1, 7, and 1, 8. So the domain is being paired with 2 different ranges, not a function. Another way to test if something is a function is called the vertical line test. So we're determining if a relation is a function if for each value of x in the domain a vertical line passes through no more than one point on the graph, then we have a function. So what you want to do with this example is draw a bunch of vertical lines through those ordered pairs. If when you draw the vertical line you only hit one point each time, then we have a function. So I drew 6 vertical lines, but each vertical line only hits the function or the relation once. So this is a function. This is the vertical line test. So let's determine whether this graph is a function. We need to draw vertical lines through the graph. As I start drawing vertical lines, I can draw them very close together. Notice I'm only hitting that part of the graph one time, except when I get here. I've drawn a vertical line that's passed through the graph twice. That means we do not have a function. Now if I keep going, you can see where it happens. It happens where the little segments end and the new one begins. I'm drawing a vertical line that's hitting the graph, and let me erase the ones that did pass. These are the three that don't pass. So this is not a function. You can say that it does not pass the vertical line test. If we were to actually name those ordered pairs, name those points on the graph, you would see that we would have two domains, or one domain for two different ranges. Another vocab term is function notation, and it's another way to just write a function. It uses the f and then in parentheses an x in place of y, and you read that f of x. So function notation just means replace the y with f of x. And you can see in the example we had y equals 2x plus 3 for the equation, but writing it in function notation, we have f of x equals 2x plus 3. This will help us when we're dealing with inputs and outputs. So some examples. If f of x equals 4x minus 7, remember f of x is just function notation instead of writing y equals. We want to find each function value. So for number 6, it's asking what is f of 5, or what is the output if you input a 5 for x. So we're inputting a 5 for x, which means 4 times 5 minus 7. So f of 5 is, 4 times 5 is 20. 20 minus 7 is 13. Number 7, we want to find f of negative 6. So we're plugging a negative 6 in for x. 4 times negative 6 minus 7. F of negative 6 would equal 4 times negative 6 is negative 24 minus 7, we get negative 31. So we can find function values given an input, we can determine what the output is. On number 6, think about it like this. The independent variable is 5. That was something that was just chosen. But the dependent variable becomes the 13. It was dependent upon the 5. We got a 13 because we plugged in a 5. Try 8 and 9 on your own. We're given the function 14 plus 3x and asked to find the function value f of 4 and f of negative 7. So we're plugging in a 4 and then we're plugging in a negative 7 for x. So f of 4 would equal 14 plus 12, 26. F of negative 7, and if you need to show a little more work, that's fine. 14 plus a negative 21. And we get negative 7. So again, that output is dependent upon the input. We get negative 7 on number 9 because we plugged in a negative 7. On number 8, we got 26 as an answer because we plugged in a 4. So now if we look at our objectives from the beginning of the lesson, were we able to determine whether the relation is a function? We'll look at examples 1 through 4. If you understand and have full comprehension of those examples, then you are able to determine whether a relation is a function. You can also look at the vertical line test. Graphically, that's how you can tell if a relation is a function. Does it pass the vertical line test? Second, are you now able to write a function using function notation? So you want to look at the vocab term function notation itself And then check out examples 6 through 9. Do you understand what it means to use function notation? And that's the f of x. In class, we'll work on worksheet 8.1.